We get talking to science today. Unfortunately, we have a bunch of news stories to make our way around, and the astrophysicist, professor, and birder, Paul Wallace, with us. Hello, Pastor, Professor, astrophysicist, and bird gawker.
Hi there.
Good to see you.
See you
lots of news stories. We always start with a little weather. It's cold and windy again here in Minneapolis, but we've been told that we're out of the frigid cold for the year. We're not going to get below zero again. I was promised by a guy on the radio, and I'm taking that as a
promise.
So the skies are brightening and getting a little bit better here. Dan, how are things in South Bend, Indiana?
We got freezing rain, which is the worst of both worlds, really.
Yes, it is. That's what we get down here sometimes. I know exactly what you're talking about.
It's, messing up all the nice, pretty snow and just turning it all into a slushy, icy mess.
That's right.
Garbage.
All right. Well, astrophysicist Paul Wallace, you are in Decatur, Georgia.
We got clear skies. We're going to hit 65 today.
And Paul, I just discovered from talking to you before the show that all the robins that leave my area of the world come visit you in the wintertime.
They certainly
just flocks of robins.
They do. The ones, like I say, who can't afford to make it to Florida stop here in Atlanta, and they fill up our trees. They make lots of racket. They wake me up in the morning.
Wow.
Lots of them. And tons of blackbirds too.
Yeah. And they leave you in the summer, do they? Your birds get quieter in the summer?
No, they get loud. They sing. The robins just make this weird chattering noise this time of year. They just sort of this sort of noisy kind of unmusical sound. But in a couple of months they'll start singing, and almost every spring I hear them singing, and I'm like, what is that? And I'm confused for like 2 minutes. I'm like, oh yeah, it's a robin. Yeah, I hadn't heard it since July or August or something.
The Rockin' Robins. Boy, I've been waiting 30 seconds to tell that. The Rockin' Robins singing down there in Georgia. All right. So I heard 2 bird stories on the radio this week. One of them on Radio Lab about homing pigeons and their ability and their use in war and so on. That these pigeons, and they can't
back in the World Wars. Yeah.
How those pigeons know, and they would put messages in there when they didn't have radio communication or anything.
They fly right back home.
Just the idea that pigeons have some, which they think now might be, some people speculate that it's connected to magnetic poles, and that they're able to follow. And we're going to talk a little bit about magnetism and electromagnetism and all that today. Yeah. And I heard another one yesterday on the New York Times Daily podcast radio show about this fictitious conspiracy theory called birds aren't real.
Oh yeah.
One of my favorites. Yeah.
About birds aren't real, but they get into the real backstory on the people how it came about. It's totally fascinating. And Paul, I think for your world of like wondering how people can buy into conspiracy theories and your interest in birds overall.
Yeah.
This one is right up the alley.
Perfect combination.
I first heard about that a while back when my middle child, my at that point probably 18-year-old, came across it on the internet, and she shared it with me. Yeah.
I mean, it's fictitious. They made up sort of a mockery of conspiracy theories.
Right.
The way it all came about was quite accidental, but just got more genius as it went. And the idea is that birds were taken away by the U.S. government in the 1940s and 50s and replaced with drones.
Right, and then when they're sitting on wires, they're charging up.
Yeah.
We just went deep into this thing and figured, and they get into character and do like huge marches and take over other people's.
But unlike a lot, I mean, it's totally, it's almost entirely ironic though, right? I mean, it's
100% ironic.
Yeah.
Like 0% is not ironic. Outside of the feeling that conspiracy theories and some of that stuff are kind of dangerous, like misinformation conspiracy theories are dangerous.
Yeah.
So but they didn't start like, how do we stop conspiracy theories? It's just a great story.
They just started by poking fun at all other conspiracy theories.
A guy
I just wonder if any people really believe it. I mean, certainly somebody's come along and thought, hey, maybe they're onto something.
Yeah, well, this is partly why they've now, the founder of this thing is 23-year-old guy, broke character, which he's only ever done interviews as the head of the Birds.
That's amazing.
And he broke character because he's like, people need to know this is not real, and it's not being clear that it's not real.
Just so you guys get it.
But then he went back into character and said that he did an interview with the New York Times, and they're going to spin his words and twist it all around because the media just unbelievable.
Great.
He just came up with it accidentally. He was at some march, some pro-Trump march that was an anti-women's march. And he's in the crowd, he's looking around, and he just grabbed an old sign and thought of 3 ridiculous words to put together. That birds aren't real, and then just improv this thing, and that video went.
Oh, wow.
Oh, is that what happened?
Yeah.
Totally winged it.
Totally winged it. Look at this guy.
Hey,
If you are funny and a burger, you've got what you need.
Bird puns at the ready.
Paul, lots of things to talk about today in the science world. Boy, you start dipping into science, and somewhere in early February, all the science stories come out. We're going to talk a little bit about the James Webb telescope. We're going to talk about looking through regular telescopes, humans in Europe, current humans that now have a bunch of money they don't know what to do with are driving up the price of meteors from Mars. Black hole, a rugby ball shaped planet. Good golly, where does a person begin on
an avalanche?
Avalanche. All right. Well, let's start with this rugby shaped planet. This is before we came on here. You were saying that it's kind of a big deal that they found this planet called an exoplanet, and I didn't know what exoplanet referred to, so maybe you can help people understand that. And why this kind of matters if some little planet way out there found by the WASP, or whatever the telescope is that they found it with, so far away, why this matters so much in the world of people who look up in the sky.
Yeah, well, and like many things in astronomy, it doesn't matter in the sense of, what help us to build, better can openers. It's not going to do that. It's not going to help, practically it's not particularly helpful, but it is a little bit amusing, and it's kind of cool that we found a planet like this. So basically this planet is really big. It's about the size of Jupiter, something like that. But imagine if Jupiter were, much closer to the sun than Mercury, like a really big gas planet, really close to the sun, orbiting really quickly. So what happens is, when you get close to a massive object like the sun, basic Newtonian gravity ensures that the forces on the planet are not everywhere the same, and it ends up stretching the planet out a little bit. This happens all the time in the solar system. It's seen everywhere. They're called tidal forces, Tidal, like the tides. Tidal forces elongate the planet and make it this weird shape. It does really stretches it out along a single axis like a rugby ball. That's exactly what it does.
And last time we talked, you mentioned that the moon is responsible for the tilt of the Earth that has something to do with our seasons. Is that a similar kind of tidal force?
No, the moon is responsible for stabilizing our rotation.
It's not responsible.
That's what it is. It is responsible for the tides as well.
But not for the tip of the Earth. That's not.
Not for the tip of the Earth. No.
What's responsible for that?
It's just our particular history of bombardment of large. The Earth was built up out of smaller rocks, basically over time. Those rocks hit the Earth at different angles, at different speeds as it's being built up, and some of them are going to knock. I mean, the planets all have some angle of tilt. Each one has got its own unique angular tilt. So there's ours just happens to be 23.5 right now. It's actually changing slowly.
Oh,
yeah,
because it's on a wobble on the axis.
Yeah, it's kind of on a it's kind of on a as it spins, the axis does have a little bit of a wobble to it,
like a spinning top would do.
Yeah, and the moon helps stabilize that so it doesn't get too far off of 23.5 degrees. But the tilt itself is not due to the moon. No.
So we don't have like tilt change issues like we do climate change issues to be worried
That's right.
about.
We do,
Yeah.
but they're over super long periods of time, and they have maybe some tiny effect on the climate, but not
Well,
much.
maybe I'll start a new conspiracy theory about how the Earth is going to tip over and really mess things up.
But to do that, you'd have to admit that it's not flat first.
Maybe.
We'll work around that. So, Paul, when this says scientists have found the first squash planet, does that just mean the first one we've taken a picture of?
The first one that we have, I mean, certainly other planets that we've come across might have been squashed and sort of elongated like this, but this is the first one we have evidence. We have direct evidence of its squashedness, whereas other ones we don't.
And what we have on the screen for people that are watching the video version of this is an image from this article. That's not what they saw, right?
That's important to know. This is an artist's interpretation. Yeah, because this is not an actual photo.
Sometimes that gets a little confusing if you don't like. How do they know that this planet so far away, the WASP 103-B, is squashed? They're seeing this by
not by taking a picture of it like this. The way they do this is that this particular planet eclipses the star as it orbits. So we are basically in its orbital plane. So as it orbits, once every time it comes around, it actually passes in front of the star. And what that does is it changes the total amount of light that we see. It diminishes it, right? Because if the planet passes in front of the star, we see less of the star's light.
Mm-hmm.
And the way the way that overall light from the star changes as the planet eclipses it, the way that light changes, it's called a light curve. Details in the light curve indicate the shape of the planet.
Got it.
Go ahead.
Well, that kind of brings us to this next story about what people actually see through telescopes. I mean, I like it that people do artist renditions of what science is describing by data, but it can sort of create this idea that if you look through a really great telescope, or the James Webb telescope or the Hubble telescope, and Hubble might be different because it's actually taking real pictures, right?
Yes, by real pictures you mean?
I don't know, like when they send back those Hubble photos and stuff, those are really photos, no?
Right. But in contrast to what? The James Webb ones?
No, sorry, to an artist rendition.
Oh, yes, I'm sorry. Yes, of course. Yeah.
Okay. So sometimes these big telescopes can actually capture what we would see as an image. Mm-hmm. And sometimes they're just seeing data, and then in a news story, they make a rendition of this to make it visually interesting for the non-data science people. We ran across this article about what the universe really looks like through a telescope, and you'd said earlier before we came on that sometimes it's rather disappointing to people when they see what they actually see when they look through a telescope.
Yeah, because what they see in the news is, Hubble images, and they see these artists' interpretations of data, like the picture of the rugby ball shaped planet we just saw. They see these, and I think they think, and it's not, it's inevitable that they would think, oh, I'll see something like that, or at least maybe not quite that, but something close. But if you look through a 6-inch telescope, you'll not see those things. You really won't. But you will see some things, and there's always a little bit of adjustment of expectations. And I've done this a lot with students. I have seen them look through telescopes for the first time many times. And there's often, the moon is an exception. The moon will always get there's two things that are exceptions and one of them is the moon. And that thing there, for those of you who can see the screen, that thing there, I think that's the Dumbbell Nebula. I think that's what that is.
Yeah.
That is super dim through a small telescope. I mean, it's like a little bitty whiff of like a little ball of colorless cotton. If you know where to look, it's really faint. So it doesn't look like that. And you don't see all those stars in the background. You might see one or two of the brightest background stars.
Mm-hmm.
Those stars are actually in the foreground, not background, but you know what I mean.
Mm-hmm.
So it just doesn't look like that. But the moon is an exception. You really do see, even in a small telescope, a lot of good details.
Yeah, you can see craters, and the edge of craters and shadow is really distinct. You can make out
if you
little
watch
mountains.
And if you watch over 30 minutes, or or maybe or really over the course of a night, you can see the shadows move. You can see them change.
Do we have a telescope powerful enough to see a person on the moon from the Earth?
No. We might be able to pick out with Hubble. Might be able to pick out one of the landers.
Yeah, I think they have images of the landers, right? That's one of those.
Yeah.
Speaking of conspiracy theories,
that's what I was getting
the
at.
idea that you can take a picture of a lander on the moon sort of debunks the fake moon landing one.
Yeah. But a really committed conspiracy theorist cannot be convinced. So
Right.
They'll find some other way.
Yeah, well, you would rig that picture, of course. Yeah, I mean that's
they planted that picture on the internet too.
I don't know, but I suspect that Hubble could. I suspect Hubble could pick out a lander on the moon,
but not from the Earth. You couldn't somewhere on top of a mountain in New Mexico point a telescope at the moon.
No, I don't think so. Maybe you could. We have this thing now called adaptive optics, which really helps ground-based telescopes, rival Hubble, basically.
Really?
It's crazy how it works.
Because the problem from Earth is our atmosphere kind of messes up the optics. Is that right?
Yeah. As the light travels through the atmosphere, it gets scattered by, currents high, really high current wind currents, basically. And so it takes the image and it just moves around a lot, like it gets and ends up blurring out a lot.
I have never looked through a telescope.
Really?
Doug, you got to.
I was just sitting here thinking.
Get yourself to your local science center.
Yeah.
And look through a telescope.
Like why haven't I? The only time I've done it is when you when on top of the Sears building back when it was called that in Chicago.
Yeah.
And you're down at the people on the street. Those ones. Yeah.
Well, if you do go on a night when Saturn is up, because that's the other exception to the rule. Saturn, invariably, when students see it with the rings, they cannot believe it's the actual Saturn. They're like, is that the real thing? It's like, I feel like saying, no, it's not. We've got a little model hanging inside the telescope, with little rings around it. But they're always amazed when they see the rings of Saturn, like the actual thing.
And what size telescope would you need to see that? Like,
an 8-inch scope is great. Would gets them really well. I mean, it's not huge. It's not great detail, but you can
make out the rings.
You can, if your eyes are halfway decent, you can easily make out the rings. And anything bigger than that, 10-inch, 16-inch. And if you go to one of your science centers there in Minneapolis or wherever, they'll have something like 24-inch or a 30-inch where you really be able to see it. So you ought to do that, Doug. You really
I should do that.
I remember one time I had to go to Walmart like in the middle of the night for like diapers or something. And outside was this guy with a giant telescope just letting anybody that wanted take a look at whatever planet.
Those people are make the world go round.
Yeah. And I looked and I was like, wow, that's super cool. I'm glad you're out here at midnight.
What did you see? Do you remember?
I think he was just looking at the moon at that point. It was
okay.
But you could see, craters and mountains.
Yeah.
Yeah.
So when you say like an 8-inch, 6-inch, are those consumer level telescopes?
They're 6-inch. Yeah, I think so. You can get a pretty solid 8-inch telescope. Yeah, I think I'd call that consumer level. It's a little on the high end, on the large end. But yeah, I would say so.
Do you own telescopes as an astrophysicist? Do you? I
don't own any, no, but the college here has got a whole room full of them. Of different sizes. So, if I ever need a telescope, I've got one.
You check one out on the weekend and go.
No, but I'll be taking one to Hawaii in May.
Oh, cool.
Yeah.
All right. Well,
speaking of telescopes.
Yes.
I don't know if you want a little segue into our weekly or bi-weekly update on the James Webb telescope, but last time we reported it's in position and now it is booting up. So that's pretty exciting.
Yeah, it's unfolded and sitting out there, and now they're starting to send details to it.
They're trying to get all the detectors working. I'm excited to know that it's all unfolded and all, that physically it's lined up. They still have to adjust the mirrors. They'll have to take a few fuzzy pictures first and do a lot of calibration first. Probably in the summer when the first pictures come in, they'll be fuzzy and then they'll have to adjust the mirrors. But I'm really happy to know that it's, unfolded basically.
And apparently from this article, they said that they burned much less fuel getting it into position than they thought they might, which extended the length of time from 5 to 10 years closer to 20 years that it's going to be functioning. Yeah. I was a little shocked that they did all this work, spent all this energy and time over decades, and there was a potential that it could have 5 years worth of functional use before it ran out of fuel.
This is you probably appreciate the fact that a lot of this is just PR. I mean, I think they all knew that they were going for 20. That they were going to. That I don't think it's a real surprise to any of the scientists. I think that they set it for a 5-year lifetime, so they can say so they can say later, wow, we quadrupled the lifetime on this. They're just being, in one sense, it's good politics. They're just being cautious.
Yeah, sure.
Leaving some margin for error if they did have to use some extra fuel or whatever.
Exactly. Yeah.
Right. Because it feels like the Hubble telescope has just been around forever. Like I can't remember when it wasn't around.
Yeah. I know.
It was like decades. So I just assumed this thing. Well, I actually thought this thing might use solar power or some kind of, I don't know, little nuclear engine, or they figured out some way to keep it there super long time. But apparently they just have some liquid or gas fuel source on it.
Yeah, I think that's mostly for adjusting its position. Little rockets I'm sure that it uses solar power because it's got this huge, like almost tennis court sized foil that faces the sun, and there's no way they're going to have that much energy hitting the thing all the time and not use it. So I'm sure that a lot of it is powered by solar, but the fuel that they're talking about is for a particular purpose, which is keeping the thing at the Lagrange point, L2, keeping it in the orbit, basically, at that location.
Because at some point, they're going to run out of that fuel that keeps it moving. Yeah. Like they said, they already had to sort of adjust it back a little bit. Yeah,
the point where it's located is we call it L2, but basically it's a point between us and the sun, and it's a point of what scientists call unstable equilibrium, which is kind of like a ball on top of a hill. Right. If you balance a ball on top of a hill, it will stay there. But if there's any small push in any direction, it'll just take off and not come back. And it's kind of at the top of a hill like that. And so it's going to, on its own, it's going to slowly start drifting away. So it's got to be continually, gently pushed back into place. Yeah.
Is that what's happening with the Hubble telescope? Is that
it's in a totally different orbit. It's much closer to the Earth, and it's in basically a 90-minute orbit. It orbits the Earth once every roughly hour and a half.
Okay.
And it's not in a position like that. No.
But it's not running out of fuel. That's not why they're.
Its problem is that it needs to be continually boosted in its orbit because its orbit decays slowly over time. It does lose energy very slowly, and it will eventually come back down to Earth if it's not regularly, gently boosted.
Do we have a way to refuel the Hubble? Like, is the Hubble going to keep doing Hubble things, or is it?
It'll eventually come down. I don't know if they're going to do that. Usually they do that in a controlled way.
Interesting.
Like land it, in the Indian Ocean or something.
Yeah.
But yeah, Hubble will. I'm not sure how it'll be brought down, but eventually it'll have to come down. Remember old Skylab back in the 70s or whatever, that thing, it
Totally.
it fell, and plenty of other NASA orbiting telescopes have, been brought down basically into the atmosphere and burned up and landed somewhere in the ocean.
Or we can be like Elon Musk and smash it into the moon.
That's true. We can boost it and go crash it on Mars or something. Take a movie up.
There used to be real worry in the United States and around the world that things were going to fall from the sky. Sky junk was going to fall and hit you. I remember people having worries about that and news stories about that. That seems to have gone away, even though there's way more stuff.
And when was this, in the 70s or 80s?
70s, maybe early 80s. Yeah.
Yeah, that's probably just when the whole notion of spacecraft being deorbited sort of hit the public.
Yeah.
Hit the public psyche,
The sky is falling. Yeah.
Hit the public head. Yeah. Right. All right. Speaking of things falling into the earth, I'm still, every time you say it, I'm still mesmerized by the idea that our planet is made up of a bunch of asteroid particles colliding together and then spinning so fast it spun it into a sphere. And then on that, all this happened.
Yeah. Billions of years ago, of course, but yeah.
Sure. Well, whenever.
And it's still and it's still happening. We're still getting hit, but it's much, 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 much less than it used to be.
So of course that's going to make me just say, why is it less now than it was millions?
Because it's all been cleaned up. It's like the Earth's like a vacuum cleaner in its orbit, and it has such a larger mass than anything else anywhere near its orbit that it tends to attract any space rocks that it happens to come close to. And over time, it cleans them all up. It's like a vacuum cleaner.
All right.
Without the vacuum, right? There's no actual
vacuum since the 1890s, so I don't know how that could have worked.
A gravitational vacuum. Think of it that way.
Yeah.
All right. So apparently, meteorites are still around, and they've been found, and then they get auctioned off, and individuals or museums or whatever can buy them. And in what just is, of course, news from of course it's this way. The price of some of these meteors in auction are going up because cryptocurrency wealth people that have made all their wealth on cryptocurrency are buying them and drive because you can only buy so much marijuana apparently with your cryptocurrency. And so now they've just moved on to meteorites.
NFTs.
So the idea that like a fake currency that's actually worth nothing other than what people will pay you for it is giving people enough money to buy something else that has no value other than what people will pay you for.
Yeah, which is basically, when you think about it, not too different than normal money. But
just perfect. Do you know anything about these meteorites that people are buying? They're little chunks of Mars.
Are they from Mars? Is that because those we had found Mars rocks on the Earth?
Yeah, this one, the one that's in the article that we're referencing here. A meteorite auction takes off thanks to crypto.
I just hope people put those in. Great if they want to buy them, some sort of investment or whatever, good for them. But I really hope that they put, if it's actually a Mars rock, which we found a handful of them. Then they really should make that publicly, and put it in a museum or someplace where people can see it, because that's awesome. And I hope they're not just buying these and putting them in their own little private homes, just for them and their friends to drool over or whatever.
Well, what I see here in the article is they're sitting in like little boxes. It looks like they're being displayed somewhere. So I don't know if they're...
Yeah, well, that's awesome.
The ones that they're selling, that anybody is selling, that some auction house has and is selling them to crypto billionaires, are ones that researchers are done with, I'm assuming. If they're doing a public auction and making a news story out of it, people are probably finding some way to buy illegal meteorites, with cryptocurrency that can't be tracked.
I wonder about that. Yeah, I wonder. I would think that these sort of things should be held by researchers, like you said, because there's not too many Mars rocks on Earth. There really are not. You know how we find them? We find them at the Antarctic. because because they stand out against this. You can, it's crazy, but you go to the Antarctic and you just walk around and essentially just look around for dark rocks, which have no business being there, right, on the surface. But they believe they came from impacts on Mars. The material was ejected up. Something struck Mars a few million years ago, threw a bunch of Mars rocks up into space, and some of those ended up landing on the Earth. Most of them landed in the oceans or somewhere else, but some of them, the ones that are easily found are found at the poles, at the where the ice is.
Well, this article says that the auction is running February 9th through the 23rd. And it's if you want to go to it, you can go to just onlineonly.christie's.com, which Christie's auction house is selling it. And it's a sale for the, quote, deep impact Martian, lunar, and other rare meteorites.
Yeah,
sale.
Yeah. That's the term.
That's familiar to you? You know that phrase?
Yeah. I'm amazed they're being, I don't know. It's like
you're like, why aren't we studying these more?
Why aren't we studying these, or at least making them? Like you go to the Air and Space Museum in Washington, you can go touch a moon rock, right? They ought to put this up in some museum. You can go touch a Mars rock.
Totally.
Yeah.
It's what Christie calls the third largest piece of Mars on Earth, and it's estimated from $500,000 to $800,000.
Wow.
Yeah. And there is some museum that has the picture of a dog house that was punctured by a meteorite that came flying in, and
that's awesome.
And you think it's from there.
Hope the dog's okay.
Yeah, these meteorites still crashing into the Earth. Yeah. So at some point, Mars had pieces of it breaking off, or it was exploding pieces of its own self out.
If there was a big impact, if a meteorite struck Mars in the same way they strike the Earth occasionally, it throws Mars junk up into space, right? It's just a huge impact crater, and it throws Mars junk up into space, and some of it is going fast enough to escape Mars's gravity. Eventually comes close to Earth and gets pulled to Earth's surface. Mm-hmm. There's probably pieces of Earth on Mars too. It's just the way it goes.
It's like a splash into a pool. These meteors are popping back up, and enough to get out of the gravitational pull of the planet. Yeah,
right. It's known as escape velocity. If you achieve what's called escape velocity, then they'll be going fast enough to not return to the surface.
Is it easier for stuff to escape Mars because the atmosphere is not as thick and dense as us?
Yeah, it's more likely for Mars stuff. And also the gravity is not as strong. Mars is smaller and less massive, so the gravity is not as strong. So a smaller impact would produce, enough stuff. It requires a smaller impact to have that material ejected from Mars. It could happen from Earth going the other direction as well, but it would just require a much larger impact. Mm-hmm. And these rocks probably bopped around the inner solar system for several hundred million years could have been before they were finally landed on Earth. They didn't make like a straight path here, probably.
And would this rock have been much larger and parts of it burned away in our atmosphere, or is it probably largely intact?
No, it probably is a fragment from something larger, most likely. And if it's not a fragment, then it's certainly smaller than it was when it entered the atmosphere, because a lot of it would have been burned off, basically.
Every other Friday, my head just spins thinking about this stuff like that. How hard does something have to hit the Earth for something to shoot back up?
Pretty hard.
At escape velocity to get outside of. I mean, we have to make a rocket with like enormous amounts of fuel to get. I get it that it's big, but getting anything, we don't have anything on Earth that could fling a rock out of our atmosphere, right? We don't have like
a catapult.
So
it has to be going. If you ignore air resistance, which is a big factor, if it was just gravity we were working against, it'd have to be going 11.2 kilometers per second, which is about 8 miles per second.
8 miles a second. How many miles an hour is that? 8 miles per second.
It's pretty fast.
It's pretty fast.
Several tens of thousands of miles per hour, something like that.
I am not saying that birds aren't real or the earth is flat, but that just blows my mind.
Hey, you know what we should do? Sometime in the next few months or something, we ought to talk about like asteroid impacts on the Earth that have happened either with witnesses or that we know are historically just to let people know how often these things happen and how big they are and what to expect, and just sort of talk about the recent history of these things because they happen all the time.
All right, that's our next topic.
That, yeah.
We're it's gonna be a couple of weeks, 3 or 4 weeks before we're back on with this because I'm going to Mexico, but like
humble
in 2
brag.
weeks. Humble brag. Yeah. So let's do that. Let's talk about asteroid impacts because that seems important. All right, one more big piece of news. Black holes. The scientists apparently have figured out something about what's going on in black holes. And that is that there's been these release of these flares that come out of it. And they think now, by this article's reporting, that they have a big enough computer to run the calculations. And they're like, it's magnetic fields breaking apart and making magnetic forces. And that's what we're seeing inside of a black hole.
Really intense magnetic fields. Yep.
Wow.
Yep.
It kind of makes you think magnetic forces is, as cool as it is in a kid's toy or hanging something on your refrigerator, that's really there is nothing that we call anything close to life without magnetic forces. It really is the key to a lot, isn't it?
Yeah. If it wasn't for our magnetic field, we wouldn't be here on the surface of our dear planet. Thank God for our magnetic field. That's what I'm saying. And not every planet's got one, but we do.
We do because we have this big core. Is this why we know that there's a big iron core center to the Earth?
Yeah. We have other evidences as well. Seismic evidence indicates the same thing. But the magnetic field is direct evidence of a iron core, basically.
And every couple of years, there's a reminder that the magnetic poles switch at times.
They do every 250,000 years or so.
And there's all the speculation that was around a couple years ago. I don't remember if we talked about it here or not, but that they think one of these is coming, that a big shift.
We're due. Yeah, we're overdue.
Yeah. I think we're due for one, but I mean, you have to understand that they probably take, a couple thousand years to happen. It's not like, we woke up on Tuesday and now the north is south and the south is north. Now our compasses are pointing south.
But is it possible that at some point like that we are already in that switching and that the thing they're coming is that recognition that because at some point the flip happens, right? Like the flip doesn't gradually happen over time. I mean, at some point.
No, it does. I mean, from our perspective, it gradually happens. All we would ever notice is like, for example, a slow reduction in the strength of the field.
Oh, okay. All right.
And then it would sort of fall, maybe not quite to zero, but close. Eventually it would be zero, I suppose, in some sense. And then it would slowly reverse. And this whole thing would probably take a couple thousand years. And, honestly, over any single person's lifetime, all you would detect is a fairly rapid either decrease or increase in the strength of the field.
How does an average person experience the magnetic field on Earth?
You don't.
Oh,
normally.
Great.
Birds do, as we said before. Birds, we believe, have a way of sensing, almost kind of like visualizing the magnetic field. But we don't until you pull your compass out and you're lost in the woods and you pull your compass out. That's about as direct as we ever get.
Yeah. Okay. I feel like
but it's there.
wasn't paying attention. That's what a compass is doing, right? The compass is finding north because that's the northern magnetic strength. That's why a compass points to north.
Yep. It points north towards the Earth's. Well, there's a couple. I'm not sure how deep a hole you want to go down here, but the Earth's geographic North Pole, like what we call the North Pole, is a south magnetic pole, and our little compass is just a magnet, and the North Pole of our magnet is attracted to the South Pole of the Earth, so it points toward the South Magnetic Pole, which is in the geographic north. It's called the North because the North Pole of our magnets points that way.
Because the other end is where we put the pointer rather than on the magnetic end, the round magnetic end.
Right. So anyway, so it points north, but that field, it changes gradually all the time. And I'm not sure if it's getting stronger or weaker right now. It might be getting weaker.
Are there any of our technologies that are dependent on the magnetic forces? And
gosh, there should be something.
Like with
anytime,
GPS,
your GPS. I mean, you have a little, if you ever pull your phone out and you can rotate it and you can see the orientation of your phone change on your map there, on the phone itself. That's all magnetic.
It is. So the phone's not just a digital version of that. It's actually.
No. When you pull your little compass out on your phone, you got a little compass on your phone. That's a magnetic thing. There's a little magnetic field sensor in your phone.
Well, that's kind of cool.
Thanks.
Because you can. There's GPS, which tells you where your phone is, but you can hold your phone in one location and rotate it, and it knows what its orientation is. That's magnetic.
I didn't assume that was mechanical or magnetic. I just assumed that was a digital representation of such things.
I believe it's a digital representation of. I mean, basically, there's a magnetic field sensor inside your phone.
Well, I want to believe that too. So let's believe that. Believe that together, because that's way cooler. All right. So one last story that sort of struck my eye was this discovery that human beings were living along Neanderthals in Europe 10,000 years earlier than people thought. So back to 50 or nearly 60,000 years ago, because people were excavating in a cave and found a little baby tooth right in the same sediment layer with Neanderthal things. And apparently the cave had been abandoned by Neanderthals, and then Homo sapiens were roaming around and came and took it over, which means, as the article says, the article is discovery pushes back the age of early humans in Europe by nearly 10,000 years. That 60,000 years ago, humans were colonizing other areas. Like they were just on the move. Like our species has been roaming this planet, from the time where there were just spears and rocks carved into pointy things.
Yeah, and that wasn't so long ago, as far as the overall, arc of life goes. It was really recently. It's crazy.
Yeah, and that human beings are just a nomadic species. I think about all implications about immigration and also colonization, because it's easy to think, and there's a lot of conversation in our society that feels like everybody should just stay where they're born. Because how do you make sense of, like, I don't know, people from, in the 1500s came and took people's lands, and like it feels horrible and socially painful and all of that. The alternative is don't do that. Or if you go there, then you don't take those lands. But this is somehow built into our evolution that to do this right, to explore and not take over and dominate people, we're overcoming something that has been going on for 60,000 years, and we don't seem to have the tools to overcome that in a way that we need to.
Yeah, we have always been on the move. Always.
Easy.
Yeah.
Well, that's part of how we've survived, likely, right? Like following food sources.
Yeah, right. No, we've never stopped moving. Stay where you are. I love that. Everybody, right now, starting today, Stay where you are.
Yep.
Big game
Just
of cultural
stop.
freeze
Just
tag.
stop.
Just but yeah, and just think about like for any of us that have had to move in our modern age, or even go on vacation or go on a trip,
Yeah.
or the people we met that were coming from Guatemala or Honduras, Nicaragua, up to the U.S.-Mexico border, like a 3,000-mile journey. But there's an infrastructure, and then you just keep going back in time when like, wow, that was much harder to move around then and much harder to move around then. 50,000 years ago, when the Homo sapien brain wasn't even fully where we are now, following food sources, sure. But I couldn't follow a food source right now. Like, I would have no idea of like, how do I follow food sources and go capture them? It just is, it's really
not
quite
only that, but the way we spread across, the South Pacific Islands on these little boats, and then came across the the Aleutians, and into from Russia, what we call Russia, into Alaska, and across the strait up there, and it's just crazy.
Mm-hmm.
crazy.
Absolutely bonkers. Speaking of trips, though, you're going to be in Mexico.
Yes.
What's you going to be doing in Mexico?
Laying flat and pointing at the sun like the cover on the James
good for you.
I'm going to be like the shield over a small part around a pool, protecting it from the sun.
Well, that's important. That's important work. I'm glad somebody's doing it.
We're all very happy for you.
In February, Shelley and I tend to go on a sun vacation, so we're going to go.
That'll be good.
The Cancun area, Playa del Carmen area of Mexico.
Get that vitamin D.
Get that vitamin D, and
you Northerners need it. You don't get enough of it these days.
Well, I don't know if we need it. We just choose to make it a thing that we enjoy. So
yeah, well, good.
We try to tell our, so we try, like a lot of vacationers, when you vacation, you can create a story by which, yes, going away for some number of days is somehow
necessary.
Yeah, a necessary act of heroism,
right.
Yeah, we do. I mean, absolutely. Wait, hey, take your responsibility to, that feels better. But, so we're going to do that. So I will be here next Friday, but then gone the Friday after that. So, which is our normal Friday. I guess we'll be back with this conversation, unless you guys want to talk about asteroid.
We might just talk about asteroids and craters without you. I don't know.
Yeah.
Hey, could we have like a numbers week? I talk about weird number things, and it's not really science, it's not really astronomy, but there's so many great little games we could play, and like just unbelievable things about numbers that I don't know.
Like you're a math guy right now. You're nerding into your math capacities.
Yeah, and I want to suck y'all into it. I want to suck all the listeners into it because I got like 5 or 6 great things we could talk about that would just blow your minds.
All right, let's decide in 3 weeks. Are we back with asteroids and collisions, or with?
Let's do the asteroids. Let's go ahead and do that one.
Yeah,
I like that one.
All right, and then we'll talk about some numbers. It'll be a numbers game.
Yeah. Great. So I'll get some asteroid stories lined up.
Nice.
All right. Hey, you're a professor. You have some students today. What are you going to be teaching them on this fine Friday?
Strangely enough, we're going to get our first crash course about the magnetic field and magnetic forces.
Do you bring a bunch of magnets into your classroom for these?
Sure, I do.
Students, yeah.
Little compasses for everybody. Yeah, this is a lot of fun.
Nice.
They can't take them home though. We don't have that kind of money.
Really?
They got compasses on their phones.
That's right. I was just thinking, they all can afford a $300 to $1,000 phone, but they can't afford a $29 compass.
Right. It's probably more like a $3 compass. These things.
Oh, is that right? Hey, when I was in school, the compass was not only that. Am I right? Is my memory right? It's not only the thing that shows you where north and south is, but it's the thing with the pointy end on one side and a pencil on the other, and you spin it around. That circumference thing. Isn't that a compass? That thing? Isn't that called a compass?
Yeah. Isn't that?
I don't even know what you're. about? What are you talking
So,
about?
like in math,
For
or
drawing like a circle or a...
Oh, yes. A pointy thing with a pencil on the other end. Yes. That is called a
That's
compass.
the technical term.
the
A little
compass,
silver thing
yeah.
with a little clip on it that would clip your pencil onto it. Yeah.
Yeah.
Yes.
That is
Yes.
called a compass. Yes.
Yeah, that was a bad choice of naming two very different things the same word.
Mm-hmm. But they both have to do with sort of circles and stuff.
Yeah,
So
yeah, because I went on a Cub Scout trip and they said bring your compass, so we're out there in the woods. And I'm out there with a little pointy thing and a pencil.
I'm ready. Let's go camping.
Lost for weeks. I was lost for weeks.
I don't know how this helps me when I get lost, but I'll take it anyway. They said to bring a compass.
Of some degrees. All right, Paul. Well, thanks for such a great chat today. Good luck with the kids, and
Thanks a lot.
We'll talk asteroid collisions pretty soon. Anything else, Dan?
Nope. Good to go.
All right. Well, thanks, Peggy. Thanks. Okay, let's go. Thanks, Mike. Thanks, Zario. Pagitt, can you put that comment up, because it's such a good reminder that the Russians aren't done with us yet. So we just get these bots, and we always have these kinds of names that give us these comments that somehow must try.
Is it a link? I don't even know. What am I supposed to do with that?
No, I don't know.
They have an actual word there, which is nice.
Voom today.
Voom today.
Normally, can't even. It's not even a word. It's barely a word scramble.
That's a good name, though. You got to admit, that's a good name. You need to use that in a novel or a movie or something. Zario Pagitt.
Zario Pagitt and Voom today. That's the comment that was made. Hey, Paul, are you into Wordle?
Yeah. Oh, but there's another one too. There's Wordle, which I do absolutely, but there's another one called Birdle.
Of course there is.
Birds have like a 4-letter banding code, like the Northern Cardinal is NOCA. And so you got to pick the 4-letter banding code, but it's called Birdle, which is BRDL. Birdle.
That's hilarious.
And it's only 4 letters instead of 5. Because
but it's no easier, I assure you. Because you don't have to have vowels.
Right, that sounds way harder.
Yeah, and you got to know your birds a little bit.
You have to know the banning codes.
Yeah, and there's a formula for figuring them out. It's not that hard, but yeah. So yeah, I do Wordle. How about you?
No, I haven't done Wordle yet.
Oh, I love it.
You haven't?
It's great.
No,
just on principle. It's a zeitgeist, so you're gonna.
Well, when I first heard about it, I thought it was closer to a crossword puzzle. Before I sort of knew, and those things just stress me out. I don't know. I always sort of avoided, like fill letters into boxes things.
Yeah.
Because I just got stressed out. I know some people really are great and love a crossword puzzle, and I can see why. But to me, it's just whatever people enjoy about that, I don't tend to enjoy. And then it just sort of became, I don't know. I haven't Wordled yet, and somehow people asking, "Do you Wordle?" and I said no, became a reinforcing thing that I don't Wordle. So
right. It became your thing.
I guess I should Wordle.
Yeah, some people just don't enjoy nice things. And
3 or 4 years from now, when nobody else is talking about it, you'll pick it up. Hey, this is kind of fun. Y'all notice this? You ever done this before?
Hey, I had to spend $42 to get this and pay the New York Times. So I could
right.
People like, we played that for a year for free before the New York Times took it from us.
It, yeah.
Well, all right. So I don't know how we went back down that road. You got to go teach those fine minds of St. Agnes College.
I do.
St. Agnes? No. St. Agnes?
It's Agnes Scott. That'd be cool.
Scott.
St. Agnes would be cool. I'd be in favor of that, but no. It's Agnes Scott. We just call it Agnes.
Yeah.
We go by the first name. We don't call it Scott. We call it Agnes down here.
Yeah.
First name basis.
So I text my wife and I'm like, I'm leaving Agnes. She's like, well, you damn well better leave Agnes, whoever Agnes is.
Are they the Aggies? Do they have sports teams?
No, they're Scotties. It's horrible. It's not a good mascot. The little dogs. I mean, I don't know.
My kid's school is the Scotties. We're the Swanson Scotties.
Are you? All right.
Yeah.
Well, maybe. Okay. I've never heard of another Scotty.
You guys share stuff. Send some.
Got some Scotty swag.
They have this mascot though, and it just looks. It's like they're trying to make a Scotty look aggressive. And it's like
a muscular Scotty dog.
It's not. It doesn't work.
Is there a mascot at either of these schools, the college or the elementary school, where someone dresses?
Yeah, we've got a full costume that someone wears and runs around in. One time they did flips like on a trampoline and slam dunks.
Wow. With a big Scotty dog head on?
Yep.
Wow, how funny. I've not seen anything like that here.
No?
We'll let you borrow ours.
Yeah. Grab that telescope and start going around looking for the Scotty mascot to tell people that you're hunting for the Scotty mascot. All right. We were leaving this conversation a few minutes ago. Maybe
we were. That's right. I got to run.
All right. Bye, everybody.
See you. Have a good time in old Mexico there, Doug.
Thank you. Hey, everybody.
Care.
Try to love one another today. How about that?
Sounds good.